Hey there, welcome to Cambridge Learn Academy. On this video, we're going to discuss the nature of the roots. So in order for you to master 1.3 of your question paper, the last question of your question paper, question 1, you need to understand the nature of the roots. So first thing first, let's start by describing what we mean by the name nature. When we talk about the word nature or nature of the root, this one, it refers to the type. It refers to the type of numbers that the roots are. So when we talk about the nature of the roots, it refers to the type of the numbers that the roots are. So now when we talk about the roots, remember, the roots are the x-intercept. These are your x-intercept. We are talking about the x-intercepts, or we can say the solutions of a quadratic equation. The solutions. Right. So now, when in order for you to master this concept, you need to understand how to use this formula. The quadratic formula. You need to understand how to use the quadratic. So now, this is your quadratic formula. Most of the time they give you this formula in a formula sheet, and it says that x is equals to minus b plus or minus the square root of b squared minus 4ac, and everything is divided by 2a. Right. So remember that the standard form of a quadratic formula is ax squared plus bx plus c. So on this standard form, you need to understand what is a, you need to understand what is b. Remember that a is the coefficient of what? A is the coefficient of x squared. So a is the coefficient. This is your coefficient of x squared, meaning that this a, we're going to take, to find the value of a, we just write down the number that is in front of your x squared. That's the first thing that you need to understand. The second one is the value of b. Remember that the value of b, this will be the coefficient. This will be the coefficient of what? The coefficient of x. So any number that is in front of x on your quadratic equation, it will be the value of b. The last one is c, which is your constant. This is your constant term. Your constant term. This one, we don't have any variable on the value of c. So now that you understand the quadratic formula, we can try and explain what we mean by the nature of the roots. So remember that, let's say that you are given an equation like this: 3x squared plus 2x minus 4 is equal to 0. So now what I need you guys to know is that the quadratic formula, most of the time we use this formula to do what? The quadratic formula is used, this is used to factorize. We can use it to factorize or solve for x, where you are given a quadratic equation. Right. So now let's use this equation to do what? Let's use this equation to solve this guy here. Remember, we said the equation says minus b plus or minus the square root of b squared minus 4ac, and everything is divided by 2a. So from this formula, you just have to know what is the value of a, what is the value of b, and what is the value of c, and you need to do what we call a direct substitution. So now remember, we said the value of a is what? The value of a is the coefficient of x squared. Is the number that is in front of x squared, and that number is 3 from this formula. And the value of b is the coefficient of x. We have 2 in front of x, and we have c, which is the constant value. Please make sure that you take the value of c with the sign. It's very important that you take the value of c with the sign. So now this is just a recipe. You just have to plug in the ingredients and follow the steps. So let's plug this, guys. So we have minus, where there's b we need to put 2, close the bracket, plus or minus the square root of what? Where there's b, remember, this is 2 squared minus 4. The value of a, we said this is 3. The value of c is minus 4. Everything divide by 2 into the value of a, which is 3. So what I need you guys to do is that you can then solve for x. You can then solve for x from this thing. You can solve for x. You can punch this on the calculator to find the value of x. So most of the time in an exam, they'll say round your answer into 2 decimal places. But remember, this video is more about the nature of the roots. So when we talk about the nature of the roots, we're going to put our main focus on what you have inside the square root. This. So what you have inside the square root, we call that equation the discriminant. So this is what I want us to talk about on this video. The discriminant. The discriminant. So the discriminant, it's indicated by delta. So delta, it's equals to what you have inside the square root. Remember, inside the square root is b squared minus 4ac. So the discriminant is equal to b squared minus 4ac. So in an exam, you'll be required to calculate the nature of the root. So in order for you to calculate the nature of the roots, you need to understand the discriminant. Remember, this is just an introduction to nature of the roots. So now, if I have from the given, let's say from the given equation, this one, the first equation where we have 3x squared plus 2x minus 4. To find the discriminant, we're going to take this equation and equate it to 0. That will be your discriminant. The answer that you get, it will be your discriminant. So if we can rewrite this, here is b squared. We said the value of a is 2. So we're going to write this down. The value of a is 2 squared minus 4 into the value of b. The value of a we said is 3. And the value of b, this will be 3 into minus 4. So this is the discriminant. Therefore, if you punch that on the calculator, you'll be able to know what is the discriminant of that quadratic equation. Okay. So now, you need to understand when we say we have 2 real roots on an equation, you need to also to know when we have 1 real root and also when we have non-real roots. So let's say that on the given equation, you find that the value of a is greater than 0. Remember, this is a quadratic function. If I have ax squared plus bx plus c, this is a quadratic function. If the value of a is greater than 0, remember we're going to have what? We're going to have what we call a happy face. Right, we're going to have a happy face. So our graph will be concave up. So if our graph is concave up, so when it's like this, when we count the number of roots, let us quickly highlight that on the graph. So we have 1, 2 roots. So we're going to say this has 2 real roots. Right, that's the first case. So if the value of a, is concave down, it means that the value of a is less than 0. Our graph will be concave down. So our graph will be concave down. It will have a set face. So when it has a set face, we can see that we have the roots there. this will be our 2 roots, which is 1, 2. So if the value of a is greater than 0, and if the value of a is less than 0, this is how your graph will look like. So now remember that this one, we say this is where it has 2 real roots. So let's talk about the case where we have the value of a greater than 0, but we have what? We have 1 real root. We have 1 real root. So if we have 1 real root, we're going to say that, let's say this is our graph like this. This is our Cartesian plane. We have 1 real root, so this will be concave up. So when we have 1 real root, it will only do what? It will only touch the x-intercept only once. It will touch the x-intercept only once. So this is how you see how many roots your graph have. So in this case, we're going to say this have 1 real root, which is only that one. Same will apply if the value of a is less than 0. If a is less than 0, it will be concave down. So now the last one that I want us to talk about is when we have no roots. So when you have no roots, means that we have 0 roots, no real roots. Let's say no real roots. So your graph will look like this. Your graph will look like this. So your graph will be, let's say that a is greater than 0, your graph will be concave up. So you can see that on this graph we don't have the x-intercept. We don't have the x-intercept, so we can say that this has no real roots. Right. So now the last thing that we can discuss is how do you determine the nature of the roots? How do you determine the nature of the roots? So in order for you to be able to determine the nature of the roots, you need to understand this table. Let's say, remember that we said the discriminant. We use what? We use the discriminant to determine the nature of the roots. So when I have the discriminant like this, I can have, let's say that I have the discriminant that is greater or equal to 0. So if the discriminant is greater or equal to 0, we're going to have a real roots. We'll have real roots. And if the discriminant is less than or equals to, okay, let's say it's less than, it won't be equal to 0, but it's less than 0, means that the discriminant is negative. If you calculate your discriminant and you find that it's negative, we're going to have no real roots. So this one will have no real roots. So now, but if the discriminant is greater or equal to 0, it's either you're going to have, you can have what we say, the discriminant can be equal to 0. If it's equal to 0, you'll have 2 equal roots. You'll have 2 equal roots. Right, don't worry guys, this will make sense when we do examples on the next video. This will make sense when we do examples. So now, if the discriminant is greater than 0, if the discriminant is greater than 0, you'll have 2 unequal roots. Right, you'll have 2 unequal roots. So now this will be the end, but for discriminant greater than equal to 0 will be the end. But for this one, we can say that if the discriminant is not a perfect square, if the discriminant is not a perfect square, we can say that it is irrational. The nature of the root will be, it will have irrational roots. But if the discriminant is equal to a perfect square, you're going to say that if it is equal to a perfect square, you're going to say that it will have rational roots. So this is the information that you need to understand in order for you to master the nature, how to determine the nature of the roots. So on our next video, we're going to do some of the example and also how to use this table. Okay, thank you very much for watching. I'll see you guys on our next video where we're going to do multiple examples.